Now continue to run analysis and design. Click on design, setting, analysis. View the first order elastic analysis. After run analysis, we will check alpha critical. Click OK. Click on design or static. The ratio file 1.69 status file 6 column. Now we fix it. Come back. Check the restraint is correct or not. Restraint. Okay. For the beam, check for the beam. Yeah, we check the lateral, top and bottom. Set it. Set it. Control C. Come back to the model. Turn off wind panel and rose panel. Left view. Click on the 3 column and change the section. Change the section to 600 and change the grade to 490 for this column. And for this column, we can select it. Control select. Change the steel grade to SE 440. So this 6 column, yeah, the 6 column we use 490 megapascal and section ISP NPB 600 multiplied with 220. So the wind wall and rose panel, select on the wind wall and change the decompose to the member. Yeah, we want to decompose load directly to the member on the columns. For the other wall, change it on the member. This one also the same, change on the member. On the member, select on the row sheet. You see the row slope is 7.59. You see how you can check the row angle by using a row sheet. Change it to the dual pitch. Okay. Escape. Change. Save it. Check in design setting. Check the sway and twist check. Okay, we limit it L over 150, correct? And come back to design static all again. Okay, now check for the twist. Yes, twist is okay, wind twist. overall trees and sway, no matter, and you can check for other member. What is this? You can fit it. So now we pass all the member for our design requirements. Here the purlin failed because the compression fault. You can release it by using the select the member. Yes, select the purlin and check in the release to release axial force. Yeah, release axial force. It is how you can design for the purlin. We use purlin for the gravity load only, and for the lateral load we use the pressing system. What is the pressing system? Yeah, this beam, and it pressing is the pressing system in our structure. We use it the main part of the resisting lateral force. Do not use the purlin resisting lateral force. I hope you enjoyed this tutorial. We will continue to the next step. Click on the review view to check the ratio. This is the design ratio 0.98 and 0.82 0.82 for the raster 0.82. Steel grade ESE 440, and for the 6 column, yeah, 6 column we use steel grade SE 440. The design ratio is 0.98. Check the status. Pass all. Okay. You can show the result in a tabular data, and select on the design summary. Click on steel and column. Check the utilization ratio. Click on it again, the maximum, and check for the result. It's pan all. Scroll down to check the design report. Column to check the maximum design ratio is 0.98. Click on the result. It's pan all. Check for the class 1. Slender, axial, and buckling. Yes, buckling, lateral torsional buckling. We press it at the 7.2 meter, 6.4 meter, and 5.6 meter. So we press the column every girth. Yes, every girth intersect with the column. We press it at the compression plane or at the bottom plane of the columns. Can check for design summarize where this is the alpha critical greater than 10, so you can keep in the first order analysis in order for the structure. Change for the sphere to the wind trees. Okay, materially you can check for the material, beam and column press, floor area. Design summary for the press member. Click on the press, and you can optimize the pressing system. Yes, to check and optimize each one by one. This is how you can design and check the result in Tekla Structural Designer. I hope you enjoyed this tutorial. Thank you for your watching.